Every impossible megaproject looks like a triumph on opening day, but the real cost begins after the cameras leave, when complexity, risk, and permanent maintenance quietly take over. For decades, megaprojects have been framed as symbols of progress, ambition, and national capability. Record-breaking bridges, tunnels drilled through mountains, cities built on reclaimed land, railways across deserts, and energy systems operating at continental scale are often presented as triumphs of human ingenuity. Yet behind every impossible megaproject lies a reality that is rarely discussed openly, because its true cost is not measured only in money, materials, or time, but in risk, fragility, and long-term consequences that extend far beyond the construction phase itself. In the modern era, countries no longer pursue megaprojects simply to solve practical problems. They pursue them to secure logistics dominance, energy resilience, geopolitical leverage, and economic signaling. China, the United States, and Europe all engage in this competition, albeit through different models of governance, financing, and execution. What unites them is a willingness to push infrastructure into environments and scales that previous generations would have considered unreasonable or outright unbuildable. The first hidden cost of impossible megaprojects is complexity. As scale increases, systems stop behaving predictably. A bridge is no longer just a structure, it becomes a network of materials, sensors, maintenance cycles, weather interactions, and human behavior. A high-speed rail corridor is not simply track and trains, but an ecosystem involving energy supply, land use, signaling automation, cybersecurity, and long-term operational stability. Complexity does not grow linearly. It compounds, and with it, the probability of unexpected failure. China's large-scale infrastructure illustrates this reality clearly. Projects such as high-altitude railways, massive dams, and desert-spanning energy corridors succeed not because risk is eliminated, but because it is absorbed at scale. Entire institutions are built around managing uncertainty, deploying redundancy, and accepting inefficiency as the price of resilience. The cost is not just financial, it is organizational. Megaprojects demand centralized coordination, constant monitoring, and long-term political commitment that can crowd out alternative investments. In contrast, Western megaprojects often face a different set of hidden costs. In Europe and the United States, regulatory complexity, public opposition, and legal fragmentation stretch timelines far beyond original projections. Delays are not merely inconvenient, they fundamentally alter the economics of projects, increasing exposure to inflation, technological obsolescence, and shifting political priorities. An impossible project does not fail all at once, it erodes slowly through compromise. Another often overlooked cost is human endurance. Extreme megaprojects are frequently built in environments that test the limits of both machinery and the human body. High-altitude construction weakens workers through oxygen deprivation. Desert projects expose crews to lethal heat. Arctic infrastructure operates in conditions that degrade materials and impair decision-making. While automation and robotics reduce exposure, they do not remove it entirely. Human labor remains embedded in every stage of construction, maintenance, and emergency response. This leads to a deeper cost rarely captured in project reports: cognitive strain. Long-duration megaprojects demand sustained attention, discipline, and coordination across years or decades. Fatigue accumulates not just physically, but organizationally. Mistakes made under pressure are not always dramatic, they are subtle, compounding over time until they surface as structural weaknesses, safety incidents, or systemic inefficiencies. Environmental trade-offs represent another hidden layer. Megaprojects designed to solve one problem often generate secondary consequences elsewhere. Dams stabilize energy and water supply while altering ecosystems downstream. Coastal defenses protect urban centers while increasing erosion in neighboring regions. Large-scale land reclamation reshapes coastlines but introduces long-term subsidence risks. These effects are not always immediate, but they lock societies into paths that are difficult to reverse. The economic cost structure of impossible megaprojects is equally deceptive. Initial budgets rarely reflect full lifecycle expenses. Maintenance, retrofitting, technological upgrades, and climate adaptation extend costs far beyond construction. Infrastructure built under one set of environmental assumptions must now survive under rapidly changing conditions, increasing the burden on future generations. The real price of a megaproject is paid not at completion, but over decades of operation. Automation and advanced technology are often presented as solutions to these challenges, and in many ways they are. Robotics, AI-driven monitoring, and predictive maintenance allow megaprojects to function under conditions that would otherwise be unmanageable. Yet these technologies introduce their own dependencies. Software requires updates. Sensors fail. Cybersecurity becomes critical infrastructure. The system becomes more capable, but also more sensitive to disruption. Geopolitically, the pursuit of impossible megaprojects carries strategic costs as well. Infrastructure at extreme scale creates fixed assets that are difficult to adapt or abandon. Once built, they shape trade routes, military planning, and diplomatic relationships. A miscalculation can lock a nation into infrastructure that no longer aligns with economic or strategic realities, turning ambition into inertia. What makes these costs truly hidden is that they rarely appear in promotional narratives. Megaprojects are marketed through images of completion, speed, and scale. The years of strain, compromise, and trade-offs fade from public memory. Yet engineers, planners, and operators understand that success is not binary. A project can be completed and still impose long-term burdens that are only visible to those tasked with keeping it alive. This is why impossible megaprojects increasingly blur the line between engineering and governance. Decisions about design, risk tolerance, and redundancy are political choices as much as technical ones. They determine who bears the cost of failure, who benefits from success, and how resilient a society remains under stress. In this sense, megaprojects are not just infrastructure, they are expressions of national priorities encoded in concrete, steel, and algorithms. As climate volatility, geopolitical competition, and technological complexity increase, the pressure to build the impossible will only grow. More tunnels through unstable geology. More cities in hostile environments. More energy systems operating at the edge of feasibility. The question is no longer whether humanity can build such projects, but whether it fully understands what it commits to when it does. The hidden cost of building impossible megaprojects is not that they fail outright. It is that they succeed just enough to demand permanent attention, permanent resources, and permanent risk management. They become systems that must be fed, monitored, and defended indefinitely. Progress, in this context, is not a finish line. It is a long-term obligation. Ultimately, the true measure of a megaproject is not how impressive it looks at completion, but how quietly it functions decades later, under stress, without crisis. In a world increasingly defined by uncertainty, the most ambitious engineering achievements are also the most demanding. And the nations that pursue them must be prepared not only to build the impossible, but to live with it.